Good morning or afternoon or whatever it is where you're at. This is the second session, third actually, if you count down under, of DBA fundamentals for the month of February. And today we're going to have Glenn Berry with SQLskills doing high availability disaster recovery 101. So we'll get to that in just a minute. I'm going to go over a couple of things real quickly. We have our contest for the first half of the year, to where if you're a member of PASS, you're a member of our group, and you attend a session, you get one entry for each time you attend a session down under or here in the States. And at the end of 6 months, sometime around after June, we will have a drawing for a very large Amazon gift card, probably $1,000, and then probably a second and a third place. We also have another contest starting up, but we have all sorts of contests around here. We have got codes, and I'll send those codes out in the newsletter. But we have codes coming out for saving you money on going to the PASS Summit in Seattle in the fall. They have two different types of codes this year. One code that's available now will allow you to get the recordings from the 2017 PASS. If you sign up at the current price, I think it's $16.99 or something like that for the PASS Summit. And in about another month, they'll have the $150 off code coming out. So you can wait for that, or you can go ahead and get the 2017 sessions, which I think would be pretty great. You get them either, I think it's getting them online. You can pay a little bit more, get them online, and get them on a USB stick. So either one of those are pretty good, and just keep an eye out for our newsletters, and you can look for that. So anyway, I'm going to turn it over to Glenn Berry now, and this will be posted, and the session and slides will be posted within a day or two. And questions, if you can hold them to the end, would be great. Then Shane will take care of that, and Glenn will. But if you got questions in the meantime, can't hear, whatever, or if you want to ask again whether or not it's going to be posted, you can do that. But at the end, Glenn will take care of all your questions. Let me turn it over to Glenn now, and I'm going to shut up.
All right, thanks a lot. This is High Availability Disaster Recovery 101, and this is a shortened and updated version of a session I gave at the PASS 2015 Summit, as you can see from the slide. So this is a little bit more about me, just my Yay Me slide. And the important thing about this is my email, glenn@SQLskills.com. If you have any questions that you can't think of now or I don't answer during the session, please send me an email and I will definitely try to get you an answer back. And also, I'm very active on Twitter, Glenn Allen Berry. Twitter is a very good resource for the SQL Server community. So moving right along here, our agenda is that we're going to talk about the causes of downtime and data loss and how you go about planning high availability strategy, and then go over the various high availability technologies that are available with SQL Server 2017, and talk about how to plan a disaster recovery strategy, and then talk about some SQL Server 2017 disaster recovery methods and things you need to think about when you're thinking about HA and DR for SQL Server. So what is a definition of high availability? Well, it just means that something is able to be used as expected. So it might be a database, in our perspective, behind a website or an application is available to take care of whatever needs to be done for that application. And this something is protected by various technologies that are available to prevent it from becoming unavailable. So you might have your database that's protected by database mirroring or failover clustering so that it continues to be available if something bad happens. And there's many different bad things that might happen that could cause a database or a server or a data center to not be available. And the point is that your users and applications are always able to do what they have to do. So they're not just down for any long period of time. But the next question is, what is this something that we're talking about? There's lots of different somethings we could be trying to protect. So the first thing is, it could just be a table in a database. So if you were worried about one particular table being available, you can use something like transactional replication or something else that protects the entire database, like log shipping or database mirroring or an availability group. Another example is it could be a group of databases that all need to be running on the same server, and they need to be all available. So they could be protected by an availability group if you have SQL Server 2012 or newer. Another example is the entire server needs to be protected, the entire server or an instance of SQL Server. And you can protect that with traditional failover clustering. Another example is an entire data center you need to protect. And something like SAN replication can be used to replicate everything at the SAN level to a secondary data center. So there's lots of different somethings that you might want to protect depending on your situation. Now, what are the main causes of downtime and data loss? Well, you have planned downtime and unplanned downtime. And the reasons usually that you have planned downtime, probably the leading case of planned downtime is doing some sort of database maintenance. And this could be as simple as creating or rebuilding a non-clustered index or a clustered index. And if you have SQL Server Standard Edition, you've got to be very careful about working on indexes because you don't have online index operations. So you can lock up a table for a long period of time and cause an outage. And you might have to take a planned outage to do some index maintenance or create a new index with Standard Edition. Now, Enterprise Edition has online index operations, but you've got to make sure you use that online equals on keyword in your index operation. And it's also a really good idea, by the way, to use max dop equals 1 when you're doing things like creating or rebuilding an index to reduce the impact on your server while you're building that index, for example. Another thing that's a very common reason for planned downtime is if you know you're going to have to go in and delete or update a large amount of data. And if you go in and do that the academically correct way as a set-based operation, that can cause a table lock to, basically cause an unplanned outage. So you might know that and decide to take an outage to do it that way, or you might decide to do it in a different way where you nibble at the problem and just update or delete a few rows at a time rather than locking the entire table. Another very common reason for planned downtime is installing a SQL Server Service Pack or cumulative update, which I hope people are trying to do more often because Microsoft has explicitly changed their guidance to recommend that you proactively install cumulative updates as they become available. And of course, that doesn't mean throw them in production the day they come out with no testing and no plan, but you also don't want to be 2 years behind on your cumulative update. And another thing you might not be aware of is that SQL Server 2017 is not going to have any service packs. It's only going to be cumulative updates. So regardless of that, another reason for planned downtime is installing Windows updates or Microsoft updates or updating your drivers or firmware on the server itself. And if you've got the right kind of HA, DR architecture in place, you can use what are called rolling upgrades to minimize your planned downtime. So instead of going in and installing a BIOS update and then bouncing the server and waiting 15 or 20 minutes perhaps for the server to come back, if you've got something in place like database mirroring, you can do it on one side of the mirror and then fail over and then do it on the other side and fail back and just have a very short amount of downtime to do a planned maintenance event. So reasons for unplanned downtime: a data center failure, something like a natural disaster, a fire, power loss, losing network connectivity. It is possible to lose an entire data center. Now, it doesn't happen that often, but you've got to evaluate, where in the world that you live and what's the most common kinds of things that might happen. You might be vulnerable to earthquakes or hurricanes or, huge snowfall, things that could cause your entire data center to be temporarily or permanently unavailable. A more common, although not as common as it used to be, reason for unplanned downtime is the entire server fails. So if you lose a power supply and you only have one power supply, then obviously that server's down until you replace that power supply. And you might lose individual components that if you don't have the level of component redundancy that you should, that causes a server failure. And you might have Windows itself locking up and crashing. Now, modern versions of Windows Server, that doesn't happen very often, but it still does once in a while. A more common reason for unplanned downtime is some sort of an I/O subsystem failure. So depending on what RAID level you have, losing a single drive or more than one drive in a RAID array could cause downtime. You might lose your RAID controller. You might have a bug in your I/O subsystem or an out-of-date driver that causes some corruption that causes unplanned downtime. But probably the most common reason for unplanned downtime is just human error. And I actually wrote a blog post about this about a month ago about things that you can do to prevent unplanned downtime, little things as a DBA to prevent you from making little mistakes that you're like, oh, what did I just do? And suddenly you dropped a table or deleted a whole bunch of data accidentally. And this is actually the most common reason that people have unplanned downtime. And there's things you can do with HADR technologies to protect yourself against this. But there's also things you can do as a DBA to try to prevent yourself from making just a silly mistake through moments of inattention. So that's the most common reason you're going to get unplanned downtime. Now, planning an HA strategy, the first thing you should do, you shouldn't go out and say, oh yeah, I've heard that availability groups are the latest and greatest thing, and I'm just going to use those. That's the backwards way to go about it. What you need to do is talk to your business, the business stakeholders, and talk about two concepts, recovery point objective or RPO, and recovery time objective or RTO. And RPO is the maximum allowable data loss in terms of time when certain kinds, or really when any failure occurs. And of course, when you go to the business and say, well, how much data could we afford to lose in this database before it's a problem for the business? Well, usually they're going to say, well, none. We can't afford to lose any data. And what you need to do as a DBA is say, okay, well, that's really going to be hard to achieve. And it's going to probably cost more money and take more infrastructure and more of a plan. So, but if you're serious about that, I'll put together a plan to try to meet that. And we'll get together in a week or so and talk about it. And quite often when you do that and show them the price tag associated with trying to get a 0 RPO, they'll back off and say, oh, wait a minute, we can't spend that kind of money. Maybe we can afford a 5-minute RPO. But the point is you need to have this conversation and get them to agree on a specific RPO SLA. And then that's going to drive a lot of your decisions later on. And if you don't do this, the business is going to assume that the RPO is 0 because, hey, you've got SQL Server, right? And we've got you as a DBA. So how could we possibly lose any data? And that's not the case. So you've got to have a defined RPO you're trying to design for. And then recovery time objective is the maximum allowable downtime when a failure occurs. And again, there's lots of different failures. So you need to go through and come up with a list of what do we think the most likely reasons that we would have a failure. So is it human error? Is it a natural disaster where we lose the entire data center? And so for these things that we think are most likely, how long would it take us to recover right now if that happened? And then go back to the business and say, okay, if we lost the entire data center, it would take us a month to find a new data center and get new servers and get everything restored. Is that okay? And it probably wouldn't be okay, right? So then you've got to put together a budget and a plan to meet what the acceptable RTO is for different kinds of failures. And when you're talking about SLA requirements here, you need to also talk about what are called availability requirements, so the number of 9s, and make sure you understand and the business understands, does this include planned maintenance or not? That's really important as a distinction. So this is a pretty handy chart that shows the maximum allowable downtime per year and per month and per week and per day for different levels of availability. And once you get past about 3 9s and into 4 9s, it gets more and more difficult to meet these unless you've got it set up so that planned downtime doesn't count against these metrics. And in many organizations, DBAs are their bonuses or reviews are based on meeting these metrics or not. So this is very important for a lot of people. Now, SQL Server 2017 has a number of HA-related technologies that are built into the product. And I'm not going to be talking about virtualization-based HA technologies. We're just talking about SQL Server in this session. So anyways, we've got backup and restore methods. And you should have a good backup and restore plan regardless of what else you're doing. Because if everything else fails, but you've got a good set of backups that you can restore from, you can save the day. And you also shouldn't let anybody push you around and say, hey, we're doing this fancy thing with SQL Server, so we don't need to do backups anymore. That is absolutely not true. So the next thing is component redundancy. Then we'll talk about Windows failover clustering. We'll talk about availability groups, basic availability groups, database mirroring, transactional replication, peer-to-peer replication, and log shipping. We'll cover all of those just at a high level. So the first thing, again, is backup and restore methods. And you need to make sure you understand and the business understands, and in relationship to your RPO SLA that you're trying to meet, what recovery model you're going to use for all of your databases. And many of the HA technologies you might decide to use later require you to use full recovery model at all times. There's no switching to bulk logged or simple. But in some cases, you can get away with being in simple recovery model, for example, but that's not going to give you a very low RPO capability in most cases. And you need to think about first, what's your backup strategy? So you're going to take full backups every so often, and then hopefully take differential backups and then log backups if you're using full recovery model. And how often you do these backups ties into your RPO that you're going to be able to meet. Because worst case scenario in most situations is that you're going to lose everything since your last transaction log backup. You might be able to back up the tail of the log, but you might not. So you shouldn't count on that. So if you have a 15-minute RPO, for example, you should be taking log backups at least every 15 minutes. Now, differential backups can be really useful to reduce your RTO because it lets you skip restoring lots of log backups. And so you can get back online more quickly in many situations, but a lot of people don't use differential backups, sometimes because their data is so volatile, it doesn't make sense to do a differential backup. But a lot of times just because people don't even really understand how differentials work and they just don't use them. And you can do things like backup compression and making sure you're using backup checksums. And you can use mirrored backups, but I really don't like that feature, to be honest, and it's enterprise only. But there's a lot of things you can do to make your backups more reliable. And I just wrote a blog post about that, by the way, a SQL 101 blog post on SQLskills.com. And then another thing that people often neglect is the recovery strategy. You know, they think about backups, but they don't think about recovery. And what's really important for your recovery strategies is to actually test restoring your backups and have a plan for how you or the most junior DBA at your organization or even a non-DBA would actually be able to go through and restore from your latest set of backups. And something that's really important to try to make this go more quickly is to make sure that instant file initialization is enabled and that you're using backup compression. In most cases, that makes it go faster. And you can also use some backup command tuning options to make backups and restores go a lot more quickly. And keeping your virtual log file counts under control can reduce the recovery time portion of a restore. So if you've ever watched a restore and it's gotten to 99% and 100%, and then it keeps grinding for another 10 or 15 minutes, that's going through the recovery portion of the restore, and that's because you have really high VLF counts, which cause other problems on top of that. Now, something that a lot of my customers have done is using a secondary restore server. So you just have a server available that you have an automated process so that as you take backups, you try to restore that backup on this restore server. And that way, if you're doing this in an automated fashion with agent jobs, and if it ever fails, you find out now that there's a problem with the backup. And then it's also pretty common in my experience for people to not ever run DBCC check DB or run it very seldom because they're worried about what it's going to do to their production database server. So if you use this restore server, you can restore your database backups there to make sure they actually work. And then after you restore, you can run DBCC check DB to make sure there's no corruption on the restored copy. And you can use an older server or a newer desktop machine with, very fast solid state storage to make this go pretty quickly in most environments. So it doesn't have to be a huge investment to have this peace of mind of knowing that your backups are good. Now, component redundancy is something also that you should be thinking about. And a lot of times as a DBA, you're not in charge of picking the server and the components, but you should stick your nose in there a little bit, because you want to make sure that you don't have unplanned downtime because you just lost a power supply, or you lost a network connection, or you lost a single hard drive. And if you've got a highly redundant server, this can help avoid ever having to use your HADR technology, because all the Microsoft HADR technologies have some downtime associated with them. And if you're trying to meet an uptime SLA of 5 minutes per year, and you have one single unplanned reboot, and that just is probably going to blow your whole thing for the entire year. So you're trying to eliminate single points of failure in a physical server. So multiple power supplies plugged into separate circuits, that's an important second point there. Multiple network ports plugged into separate network switches, an appropriate level of RAID for all of your logical drives. And some levels of RAID are more redundant than others. So RAID 10 and RAID 50 have more protection than RAID 5 does. And then having hot swappable components. Many things like fans and power supplies can be hot swapped. And then it's a good idea to have some cold spares available. So if you've got a whole bunch of Dell R730 servers, maybe you have one extra power supply laying around, or maybe you have one extra SSD or hard drive of the type that you typically use. So if you have a failure, you can immediately replace that failed component with your cold spare, and then worrying about getting a replacement for that from Dell. However long that takes, it gives you more protection by doing that. Now, component redundancy versus HADR. Again, all these HADR technologies I'm going to talk about have some failover duration. So a traditional failover cluster instance, you've got to move your cluster resources from one node to another and then start SQL Server on that new node. And that typically takes 60 to 90 seconds. Availability groups and database mirroring, you just do a database property change, but how long the failover takes depends on your redo queue on the other side. And log shipping requires a manual failover, and you can use scripts to sort of semi-automate that, but again, there's going to be some duration of a failover. And if you have component redundancy that avoids you ever having to do an unplanned failover, that's just going to improve your uptime statistics. So again, take advantage of everything you can do at the hardware and component level to make your server more robust. And the extra hardware cost is really pretty trivial compared to your SQL Server licensing costs. But be prepared. People are going to push back and say, what do we need to do that for? Why should we waste $150 on a spare power supply that's never going to be used? But your argument is this is a mission critical database server. It's not a web server and a web farm, where if you lose one of those, probably nobody really notices. This is something that's going to cause an outage if we lose this one component. All right, so Windows failover clustering. This is an old, familiar technology, and lots of people, in IT departments are very familiar with how this works, but it's a SQL Server failover cluster implemented on a Windows Server failover cluster. And you have multiple nodes with one or more instances of SQL Server installed, and this requires some form of shared storage, and that shared storage is a single point of failure. No matter what your SAN vendor might want to tell you, the SAN could never fail. Never. Everything has triple redundancy. SANs can fail. And You can use SMB file shares, and you can use newer technologies like Storage Spaces Direct in Windows Server 2016 to avoid using a SAN for your shared storage. And if you have SQL Server 2012 or newer, you can move TempDB off of the SAN onto each local node to get better performance and to take that TempDB load off of the SAN. And failover clustering gives you instance level high availability, so it protects the entire instance. And that's really pretty cool because you can add more databases and you can add more logins and more agent jobs and any server level objects, and they're in that instance which moves from node to node. And you also have a virtual IP that your applications are connecting to, so they don't know or care if there's been a failover. I mean, there's going to be an outage when it's failing over, but they'll reconnect automatically without anything having to be changed. And the downside of failover clustering is that your failover time is longer than most of these other technologies. And a big part of this is how long crash recovery takes for each one of your databases. And every time SQL Server starts, all your databases have to go through crash recovery. And if you have a very high VLF count on your databases, crash recovery takes longer. So keep your VLF counts low. And by low, I typically mean under 100 or 200. It depends on how big the log file is, but you don't want to have 10,000 VLFs on every database because then crash recovery takes a lot longer. All right, so availability groups. Availability groups contain one or more user databases that fail over together. And it requires a Windows failover cluster instance to be installed on each node, but it doesn't require shared storage, and a lot of people don't realize that. And this was an Enterprise Edition only feature until SQL Server 2016, where they have a limited version of this that's available for Standard Edition. And an availability database is just a database that's in an availability group. And you have one read-write copy, and then you have multiple secondary copies depending on what version of SQL Server you're dealing with. And your databases have to be in full recovery model at all times to use this. And this gives you pretty fast automatic failover if you have it set up to support automatic failover. And another advantage is that you can offload some of your read-only activity to your readable secondaries. But one thing that people don't always realize is that you can't make any schema changes on the readable secondaries. So you can't add extra indexes for reporting purposes, for example. So you may not be able to replace transactional replication for reporting because of that reason. Now, basic availability groups. This is a new feature they added in 2016 Standard Edition that lets you have a primary database with one replica. And the replica can use synchronous or asynchronous commit mode, which is a nice improvement compared to database mirroring, where you can only use synchronous with Standard Edition. But there are some key limitations with this, and this is meant to replace database mirroring for Standard Edition. So you only have one replica in one location and no read access, no backups on the secondary, and only one database can be in an availability group, a basic availability group. And then if you decide to upgrade to Enterprise Edition, your basic availability group cannot be upgraded. So you're going to have to tear it down and set it up again as a regular availability group. And you can only use this on Standard Edition. Of course, if you have Enterprise Edition, you wouldn't want to use this anyways. You'd want to use a regular availability group. Now, database mirroring. This is database level high availability, and it was deprecated in SQL Server 2012. But it still works in SQL Server 2016 and 2017, and Microsoft is probably too chicken to ever remove it from the product. There was some talk they were going to remove it when 2017 was released, but they didn't do it, and I don't think they're going to do it. And so this gives you a principal database and a mirror database on separate instances of SQL Server, and only user databases can be mirrored. You can't mirror system databases. And your databases have to be in full recovery model at all times, just like availability groups. And you can do synchronous or asynchronous mirroring. And if you want to have automatic failover with this, you have to use synchronous mode with a witness instance to get automatic failover. And you can use asynchronous mirroring in Enterprise Edition. And the reason you might want to use asynchronous mirroring is if you have to mirror between instances that are far away from each other geographically, and you're worried about the network latency. Of course, with asynchronous mirroring, there's some possibility of data loss. And database mirroring gives you very fast automatic failover if you're in synchronous mode with a witness. But again, you only have a single database and it only has one mirror. So if you've got 20 databases on your instance, you've got to go in and mirror them individually. Now, transactional replication lets you go in and set up publications or set up a publication at the database level or at the individual table level, and you can filter it down to just a portion of a table. What's most common in my experience, people will go in and replicate the entire database. But anyways, the source database is called a publisher, and then the destination is a subscriber, and you can have more than one subscriber, by the way. And you've got something called a log reader agent that picks up all the write activity from the publisher and then moves that to the distribution database, so that it adds some extra read IO workload on your log file on the publisher. And then it puts more load for the distribution database, and you can have that on the same instance as your publisher or a separate instance. And you can have multiple subscribers in multiple locations. And you can add extra indexes on your subscriber databases to support reporting queries, for example. So it's very commonly used for that purpose. And it does give you some HADR capability, kind of as a side benefit. Now, peer-to-peer replication is database level protection, and it's just a sort of souped up version of transactional replication that lets you have multiple writable copies of the database. And these usually are in different data centers, and the changes in each one are sent to the peers, and they eventually, hopefully within a few seconds or a few minutes at the most, synchronize. And it's often used for scalability purposes. So you're trying to spread your write workload across multiple servers or multiple data centers. And the HA capability is just a secondary bonus. And the problem with this is that a lot of times you're going to have to go in and modify your application or your database. So if you're using identity columns, you're probably going to have to make some changes to make this work. And this requires Enterprise Edition. And not too many people in my experience actually use this, but it is available. Now, log shipping, a lot of times people don't think about this, but this gives you database level protection, and you can have multiple copies of your database in multiple locations. And again, the databases have to be in full recovery model at all times, and you don't get automatic failover. You've got to go in and do a property change, but you can write some code to sort of automate this. And so some data loss is possible with log shipping because you might lose everything since the last log backup if it didn't get copied over before you lost your primary server. And so log shipping is most commonly used for DR purposes, but it's better than nothing for HA purposes. And it can also be used to protect against user error. So you might have a log ship copy of your primary database that has a 4-hour delay before it restores. So that way, if somebody drops a table or deletes a bunch of data, if you find out about it soon enough, you can go get that from the log ship copy before it gets overwritten 4 hours later. So you've got a window there. And you can combine log shipping with other things. So you could be doing failover clustering plus log shipping, or availability groups plus log shipping. And the nice thing about log shipping is it doesn't add any extra performance overhead to the primary database because you're taking log backups anyways if you're in full recovery model. So it's pretty nice as just a very first step for HADR if you don't want to get any more complicated. Now, HA features by edition, you can see Enterprise Edition can do all sorts of cool things. All these capabilities are available in Enterprise. Standard Edition has some limitations. So you can't do partial database availability. You can't do database snapshots. You don't have online index operations. And you can only do synchronous database mirroring. And you can't do availability groups unless you do in a basic availability group in 2016 or newer. All right, planning a disaster recovery strategy. What you want to do is make sure you have a disaster recovery strategy that's set up to meet your RTO requirements. And just keep in mind that no matter what you're doing with technology and products, you might have to restore from backups. And if you have a good set of backups, you can save the day, but otherwise you might be game over. And I can't tell you, almost every week we get multiple emails at SQLskills because Paul Randall wrote DBCC check DB. So somebody will email us and say, oh, my database is corrupt. How can I fix it? Can you help me? And sometimes Paul can help, but sometimes he can't. And quite often we find out that not only is their database corrupt, but they don't have any good backups. So it's game over for that company. And we've seen that, unfortunately. So what restores you need to do if you're having to restore from backups depends on what has to be brought online first. So you might have a data loss SLA RPO and a downtime SLA RPO and multiple databases and multiple applications. And somebody has to decide ahead of time what gets first priority. And a good disaster recovery plan should be written by your most senior people who have been around the most and seen the most failures, but then it should be tested and implemented during testing by your most junior people, because they're the ones who are going to be on duty on holidays and late at night and on the weekends. And you want to try to write this so that even if no DBAs were available and just a regular server admin, that they could actually go through and follow a run book and get yourself back online. And it needs to be comprehensive and detailed. Don't just say, restore the database from backups. You've got to have detailed instructions on, okay, where are the backups and what's our naming convention? And here's a script that shows you how to do a backup, a restore sequence. And then you need to have information in there. What if something goes wrong? So you try to restore from your full backup and it doesn't work. What do? Do you call Glenn, or do you try to figure out yourself based on what's in this run book? And you need to think about human factors. So if a hurricane hits and everybody's worried about their family and their house, are they going to come into work and try to get your database back online? Some bigger companies with larger budgets, when a hurricane is coming in, they have some people that they get on a plane with their families and fly them to their secondary data center. So that way they don't have to worry about all that and they can concentrate on their job. And this disaster recovery plan needs to be tested. And every time you test it, you're going to find problems and holes. So you should go back and update and improve the plan as you test it. Now, more DR planning considerations. You need to consider possible problems that you might run into at each step of your disaster recovery process. So what happens if the server is physically damaged, has water damage or fire damage, or it just got stolen? What would you do? Do you have any spare servers? If not, can you get some servers quickly, or do you have to call Dell and wait 2 weeks for a server to show up on your loading dock? And what if the SAN is physically damaged? What if there's no power at the data center? Hopefully the data center has backup generators, but what if they run out of fuel? What if there is no data center? Could you cobble something together by going to Micro Center and buying some desktop machines to sort of limp along until you get some real servers? Where are the offsite backups stored and how do you get them back? What if the backups are corrupt? And then what if your only DBA is on vacation in China and they're not available? What would you do? Can anybody else execute this plan? All right, DR planning, people issues. And this is really important stuff, by the way. So you need to have a plan ahead of time. So who gets notified first when there's a failure? And who's responsible at each phase of the recovery? And who's the business sponsor, the person with lots of political power that can resolve disputes between the hardware people and the DBAs and the network people and the application people? And who needs to be kept informed as you're going through the process? And then this next one is really important. You need to have a policy in place ahead of time so that if something happens and you're down for a few minutes, how long can you spend troubleshooting the issue and trying to fix it before somebody makes the call to fail over to the secondary data center, if you have one. Because if that's not decided and agreed upon in advance, no matter what you do, you're going to get in trouble. Because if you spend half an hour troubleshooting it and you're down for a half an hour, or if you just after 5 minutes decide to fail over to the secondary data center and that causes all sorts of extra problems, you're going to be criticized by somebody. But if it's been agreed upon, okay, we're going to spend up to 10 minutes trying to troubleshoot and get back online. And if we can't get back online in 10 minutes in the primary data center, we'll go to the secondary, then that will keep you from getting in trouble. But somebody has to be the one who pulls the trigger and decides. Also, who's in command of the overall DR effort? And then you need to make sure you've got updated contact info for everybody who has to be involved. And it may not just be your technical people. You may pull in some business people to test that all your stuff really does work after a failover, after recovering from a disaster. And what other teams have to be involved. And then finally, something in place so that you know for sure that everything in the application works, not just a quick smoke test by going to your website. Oh yeah, it comes up, we're good. There's probably little things, little batch processes or things that are done on a nightly basis that maybe they don't work even though the rest of the application seems to work. So you need to have something in place so you can say, yes, we are completely back up after a disaster. So HADR testing, you want to actually test whatever you've put in place before going into production, if at all possible. So if you've decided, okay, we're going to use availability groups plus log shipping, and so after you've done that and built your new environment, then you need to go in and do some things that are sort of unexpected. So just go and randomly pull out a drive from one of your servers or unplug the entire server and see what happens. Or go in and just drop a table or truncate a table and see what happens. Does that break everything? And if it does, how long does it take to recover from that? Do you have a database snapshot or a SAN snapshot or a log ship copy that you can get the data back pretty quickly? Or unplug a network cable. And maybe you or your network people don't do it, but send your receptionist into the data center and say, why don't you just go unplug a cable and let's see what happens. And this sort of thing is sometimes called chaos monkey testing. So instead of doing what you expect to have happen, do something unexpected and see how the system handles that. And if it doesn't handle it like you think, see what you can do to make it handle it better. And so another thing you want to try to practice is how long does it take to do a bare metal install of the OS and of SQL Server and restore backups? Or how long does it take to do a full restore from backups? If you've got a really huge database and a fairly slow infrastructure, that can be a big deal. And if it turns out as you go through this testing that you can't meet your SLA requirements, you need to go back to the business and say, look, this is the best we can do with what we have available. So we either need to back off on this requirement or give us some more money to use to improve this. And make sure that they know what you can do before you go into production. Otherwise, you're going to get the blame if you don't meet your SLA requirements. And then the other thing you want to try to do that's harder, and I can't lie, this is harder, but you want to try to do some real life disaster testing in production. And some companies will do that where they'll just, with no warning, say, okay, we just had a disaster. The primary data centers are not available. So then they start a stopwatch and time how long it takes for you to handle that. And that's not very common, but that's what you want to aspire to so that you could handle that sort of thing and be confident that it works. So to summarize here, HADR is much more than just picking, okay, availability groups, because that's the new shiny thing from Microsoft. The important thing is to understand your RPO and RTO SLA requirements and make sure that you and the business agree on that. And also make sure you understand your budget and your infrastructure. It may be that the business wants a 0 RPO and a very, very low RTO, but they've only got a budget of $10,000. That's not going to probably work. That's just not realistic. And you need to make sure you have a good backup and restore strategy regardless of what else you're doing, because all this other stuff can fail, But as long as you have a good set of backups that you can restore from, you can save the day eventually and not lose any data. And then make sure your backups are good. This is something that so many DBAs and accidental DBAs don't think about. They take backups, but they never restore and make sure that the backups are good. And then keep in mind that you can combine HADR technology features to have a more robust solution than any single one technology gives you. So I've got some resources here. There's a couple white papers here. Paul Randall wrote one of these. Some of these are a little bit newer to handle availability groups. And then I also have 3 Pluralsight courses that I've done recently. So one is about database mirroring with a lot of demos. Another one's about log shipping with a lot of demos. And then I have one on installing and configuring SQL Server 2016 that talks about things you can do to script out your installs and get them to go more quickly, which can be really helpful in a disaster recovery situation. So that's it for the presentation, and I've got some time for some questions here. Hopefully we have a few.
I think we're up to 15 questions now, Glenn.
All right,
so
great.
We definitely have a few. I think one just off the back, because I had to ask for clarification, is you mentioned log shipping and mirroring. One of the people wanted to know, is it possible to go across versions with this?
That's a good question. You can mirror from an older version to a newer version, and that's often used to actually do an upgrade. But if you fail over from an older version to a newer version, it's a one-way trip and you can't go back. And it's the same way with log shipping. So you can do that, but it's usually used when you know you're going to upgrade and you want to try to have a very short production migration. In fact, I prefer log shipping for that, but I wouldn't do that as a normal process, because if you had one failover, then you're stuck on the newer version.
Okay, fair enough. We have a question here regarding CheckDB. They ask if you suggest doing this on the production servers, or you think it's best to move it off to another server.
Well, ideally you do it on the production server, but a lot of people are worried about the resource usage on the production server, and because of that, they don't do it. And if you're in that game, it's better to do it on a secondary server, so at least you're doing it on the restored backup. And if you found a problem on the restored backup, then you'd want to go back and run it in production to make sure it exists there too, whatever problem you ran into.
We have a question. If you use synchronous replication, then does the replica have to be in the same data center or within BC or around 60 miles?
Well, replication doesn't really have the concept of synchronous. So maybe you're thinking of database mirroring or log shipping, but with replication, you can have your subscriber databases in other data centers, and there might be a little bit more latency, so there might be a little bit out of sync with a primary, and you can actually track that with replication monitor or running queries to see what's going on there. But to answer the same question for log shipping and mirroring, if you're going to be more than about maybe 60 to 100 miles apart, you're probably going to want to use asynchronous for database mirroring. Now with log shipping, it doesn't matter because you're taking the log backup and copying it over and restoring it. So the distance doesn't matter at all for log shipping.
Actually, speaking of log shipping, this is an interesting question you might like. One of the attendees wants to know, does log shipping can help protect against corruption? Or is that right?
Well, not really. Perhaps what they're thinking of is database mirroring and availability groups have a thing called automatic page repair. So if you've got certain kinds of errors on either side of the partnership, it can request that data from the other side of the partnership and automatically fix it. So that gives you a little bit of protection against corruption. Log shipping doesn't do that for you. What it does is you have that second copy of your database, and depending on what happened, it could be that the log ship copy doesn't have the same corruption, but usually it will, because you're just taking log backups and restoring them on the other side, and so the corruption might just travel over with it.
There is actually, looking over them, quite a few questions about replication. I guess it is, people do like it as a strategy, but somebody wants to know if you would consider replication when always on HEs aren't possible.
Yeah, I mean, a lot of times people don't think of replication as an HA strategy, but again, you have the capability. There's a lot of flexibility. You can go in and just pick and choose individual tables to replicate, or you can just replicate the entire database and have a replicated copy of that database. So that gives you some HADR capability for the database with replication. I mean, the downside of replication is that it occasionally breaks. So you've got to make sure that you're prepared to possibly reinitialize your subscribers from time to time. And then there is some extra overhead from the log reader and from the distribution database. And there's things you can do to minimize that, but just be aware that that's something to consider.
Okay. Somebody wants to know if we are able to restore a system database if we have a good backup.
Oh, definitely. I mean, that's something a lot of people don't do. And if you're using the Ola Hallengren maintenance solution, for example, one of the jobs that it creates is to back up your system databases. So if you ever needed to, you can restore those. Now, they're not, in some cases, it's not quite as straightforward as restoring a user database, particularly if we're talking about the master database. But yeah, you can definitely restore them if you ever had to.
I'm going to actually try and apologize because I don't want to hit you with all these different types of questions, but they're coming in from different angles. So this one is, an attendee wants to know if you can discuss some options to stretch an on-premises SQL Server failover clustered instance across 2 on-premises data centers.
Oh, a failover cluster instance?
Yeah.
Well, I mean, natively out of the box, you can't do that, but like at the SAN level, you can do that. And, oh, I don't know. I mean, I'd have to think about that and see the specifics, but I mean, yeah, just at a basic failover cluster instance level, that's not really possible. But with third-party products or using SAN level replication, people typically, that's how they do that.
Yeah. I think most questions that start with can you discuss, it's going to be very difficult to get like a quick answer out of them.
Well, that's okay. I mean, yeah. You can throw all the questions you want at me and see if you can stump me. You probably can.
Okay. You mentioned that the differential backups are good to have. Isn't the full transactional log enough? What's the advantage of doing differential too?
Okay, well, that's a good question. The advantage is that if you, let's say that you take a full backup every night at midnight and it finishes at 1 a.m., and then you're taking log backups every 15 minutes. So then let's say that some terrible thing happens at like 11:30 p.m. the next day. Well, if all you had was your full and all your log backups, you're going to have to restore your full backup with no recovery, and then find every single log backup that finished after 1 a.m. and restore it in order with no recovery. So that's a lot of restores that are going to take longer to do and longer for you to script out, right? So if you had a differential backup that you took, say, at 12 p.m. and then maybe another one at 8 p.m., you could just skip to that 8 p.m. differential and restore it and not have to restore all the log backups before 8 p.m. So that would reduce how long it took you to do a full restore sequence. So that's the advantage of differentials in a DR situation.
All right, perfect. I'm just actually reading this one. I may have the question wrong, but I'm going to ask you anyway. So this person heard that you can do schema changes in secondary read replicas and always on availability groups. They want to know, can you enable CDC on secondary read replica databases in those availability groups?
Well, I mean, I'm not sure where they might have heard that you can do schema changes in readable secondaries, but that's not true. I mean, the only thing that happens on the secondary instance is that tempdb will create temporary statistics to try to cover for, things that would have been created in the user database, and they're created in tempdb. But In user databases, you can't make any schema changes. If you need to make a schema change, you have to enable it on your primary, and then it flows through to the secondaries. But it's not like transactional replication subscriber where you can do that sort of thing.
That's fair enough. That answers this question. We have a ask. What is your suggestion on the strategy for service pack and cumulative updates? So what is your criteria to see if they can be applied or not, or do you wait?
Well, again, Microsoft, with some urging from me and Aaron Bertrand, they changed their policy, and they have a blog post on the release services blog from about 1.5 years ago, where they got rid of all the scary language that used to be in CUs, where they would say, oh, you shouldn't apply this unless you're running into this exact problem, and you should wait for the next service pack. And because of that language, a lot of DBAs would say, oh no, I'm not going to do CUs. I'm going to wait for a service pack. But they changed that. So they want you to apply CUs because they've found that many support issues would have been avoided if you were current on your CU. Now that doesn't mean that, okay, the day the CU comes out, you just throw it into production that night with no testing. That's not what it means, but you should have a process in place so that, okay, when it comes out, I download it and throw it on a test VM and see if it seems to break anything. And then you do a little bit more detailed testing, and you have a plan for how you go about convincing yourself and your organization that this CU is not going to cause any problems. And then you have a procedure, okay, here's how we're going to do it and when we're going to do it. And so maybe there's a 2-week delay or whatever. But the point is, you want to try to stay current. And with SQL Server 2017, they said they're going to put CUs out every month for the first year. They're kind of slipping on that schedule, but they're trying to put CUs out more frequently during the first year. And CUs are good, in my opinion. They fix a lot of important issues, and they also add new features. So if you're one of those DBAs that says, oh, I don't like CUs, I'm afraid of them, I'm just not going to do them, you're missing out on a lot of important fixes and improvements by not doing that. And if you ever have a support call with Microsoft, the first thing they're going to do is find out what build number you're on. And if you're on a really old build, they might not fully support you, and or they're going to want you to update to a newer build. So it's going to make you look bad if you're 2 years old on your build and then you call Microsoft for help.
Yeah, I have heard that before, that if you open a case, they do actually ask what build you're on straight away. So that's very good advice. Okay, I think we'll only do like 2 or 3 more just because it's getting to the top of the hour and we don't want to keep you too long. Somebody asked about the feasibility on running DB on CheckDB on a secondary basic availability group in a short maintenance window. So to fail over the secondary just to run the CheckDB.
Well, I guess you could do that, but I'm not sure what that would really accomplish, because if you fell over to the secondary, your workload is running on the secondary. And in some cases, you know, the secondary doesn't have as much horsepower as the primary. I mean, it should, but in real life, it doesn't always do that. So I'm not sure what that would really do for you, because you're having to take an outage for the failover, and then you're going to put a big load on the other server anyways. So why not just do it on the main server without the failover, would be my answer. And then if you're worried about the load, have that secondary server that you run it on instead of the production server. But it's not part of an availability group is the difference. It's just a standalone server that you're restoring backups to.
Somebody asked, do you need Windows clustering for always-on availability groups, or can you install without configuring clustering?
Nope, you have to install the Windows clustering feature. But the difference is you don't have to have shared storage or any cluster resources. You just have to install that feature. And it's very common to just have local storage on each node. I mean, you can use shared storage on each node, but you want to not use the same shared storage across the different sides of it, because then you're just introducing a single point of failure across both sides of the partnership.
Perfect. And we'll see the last one. I'll take it nice and easy because we are getting lots of thank yous. Somebody asked, will you be doing a 102 lesson?
Oh, that's a good idea. I mean, I could, if I had more time, or after seeing this session, I could go in and demonstrate some of these things instead of just talking about them. So as of now, there isn't one, but that's a definite idea for the future.
That's perfect. I think like nearly everyone here would enjoy that as well, including ourselves. There is a lot more questions, but what I'll try and do is I'll try and gather them up and send it on to you if that's okay.
Yeah, that's great.
Lovely. Let's see. I'm not sure if Steve is there, so I'll just get up this. So I think that's everything. Just want to thank you, Glenn, sincerely for that great session. I mean, it's actually really impressive the amount of knowledge that you actually have and are able to cover within a single hour.
Yeah, well, thanks everybody for taking the time out in your day and listening to this. I appreciate it.
I think what we have coming up next is on the 13th of March, we have Tim Radney. He's going to do common SQL Server mistakes now to avoid them, but we will be sending out emails, and especially with the new codes for pass. So we want to thank everyone for coming, and if they have any questions, you can contact us on Twitter, Slack, or email. Thanks a lot again, Glenn.
All right, thanks.
Bye.